So writing as a single logarithm, this means simplify. But sometimes we have more than one log law all combined together. Okay? The first thing that you would probably see in part A is the adding. And you're like, ooh, I know the adding one, we multiply. You have to be careful. The adding log law on the formula sheet only works if you have one log plus one log. Here we have one log plus three logs. If you try to use the log law for adding right now, you'll lose marks because it only works. They have to be perfect for the log laws to work. It only works if it's one log plus one log. So I have a problem with this 3. But I know what some of you are thinking. We have a solution for that 3. What can I do with that 3? If you have a number in front, that's another log law. Numbers in front of logs can be moved inside the logarithm as exponents. So my step 1 here, I can do that, and I would do that first. I can move that 3 in as an exponent. Log x plus log y cubed. And then, now I have 1 log plus 1 log. The bases are the same, which is important. So I'm allowed to use my log law and multiply inside. On an exam, almost always, every time you do a log law, it's worth 1 mark. The way that the exam basically chooses its marking is anything that you learned new in grade 12 is considered 1 mark. Anything that you do from previous years is worth a half a mark. Even if you do 100 things in a row of stuff you learned from previous years, which we'll see in some questions, you get a half a mark for that. So in log questions, it's not uncommon to do a half a page of work and get a half a mark, then do 2 key things in the next 2 lines and get 2 full marks for them, and then get your final answer and get another half a mark. So this would be a 2-mark question. So I recommend doing 1 log law at a time. Because if you combine first and then do the exponent in the wrong order, or you do something, you do just show your final answer, do 1 little thing wrong, you could lose both of those marks because you've shown no work along the way.
But you need to put a bracket after the log? Or
You don't need those. It's perfectly fine if you wrote that. Okay. Just wanted to show that it was all inside there, but both would be fine. Anything written after the log becomes obvious. Now, if you had a +1 here, this brackets here is different than brackets here. So you might want to clarify if a person doesn't know. Is that +1 inside the logarithm as well? Then you need those blue brackets. Is that +1 after the logarithm? Then you would need the green brackets. So generally we use brackets when, if someone was looking at this, they might be confused. Okay? You would never write that way. This is log x times y cubed. It's confusing. I would write the y, if I wanted to write that, I'd write the y cubed in front. So it's really obvious that when I'm multiplying, that y cubed was not inside the logarithm. If I wrote the y, technically this means the same as this. But now I'm confused, right? Is this log x times y cubed, or is this log xy cubed? Right? So generally when you're multiplying by something, you put that in front, which would allow you to not write the brackets, because it'd be like, it would be stupid to write this with the y cubed afterwards, because then it causes confusion. Okay. That is A. B. I will show you a shortcut for, I'm going to show you an awesome shortcut. But I'm going to erase all this. I'll erase A because we're done with it. There we go. Here's log x plus 2 log y minus 4 log z. I'm going to do this really slow, and then I'm going to show you a shortcut. First of all, I see adding, but adding only works if you have log plus log. And we have a 2 out in front. I see subtracting, and subtracting only works if you have 1 log minus 1 log. So does it make sense that always when combining as a single logarithm, you will always, as a first step, do this exponent law, where the multiplying goes in as a power. That 2 out in front goes in as exponent. That 4 out in front goes in as an exponent. Adding is multiplying. So I could put those first 2 together by multiplying. Subtracting 2 logs with the same base is dividing inside the logarithm. So now I'm subtracting. And this is my final answer. I am going to tell you that I am perfectly fine with you going from here to here all in one step. In fact, I'd probably recommend it. And I'm going to do an extra question for you. Here we go. Does anybody know what letter is in between B and C? All right, 8.5. Okay, we're going to add an extra question in between B and C. We'll call it B.5. If I said combine as a single logarithm, and I had log A cubed minus log, log B squared plus log C to the 5 minus log D minus log, can't use E because you might think it's a number, F to the 5. I have ones in front of all of them. So technically all those exponents could have been out in front and we could have moved them in, but I'm going to assume I did that as my first step already. I want you to go directly to this because you will make less mistakes. Whatever is added will be multiplied in your denominator. So I will have A cubed and C5 in my denominator because A cubed is positive and my C5 is a positive. Whatever is subtracted, my B squared, my D, and my F to the 5, those will all be in your denominator. Whatever is added is in your numerator. Whatever is subtracted will go in your denominator, and you can do that all in one step. It'll make your life a lot easier. Otherwise, you're going to be thinking about a lot of fraction rules and doing things like subtracting, do that first. Then adding, do that second. Then I'm subtracting again, do that third. And then subtracting, I already have a fraction divided by another fraction, so I have to multiply by the reciprocal. It's doable, but it's going to be annoying. And that shortcut works beautifully. So whatever is adding, those numbers will get multiplied together in your numerator. Whatever is dividing, those numbers will get multiplied together in your denominator. Whatever is subtracted will get multiplied together in your denominator. Nice. Like that shortcut?
Oh yeah.
So you can see here, I have 2 things adding, those 2 got put together in my numerator. I have 1 thing subtracting, that's in my denominator. Perfect. Can do that all in one step. And then we're ready. So then in part C though here, what's our last one? Log 2, 6 minus 3. Oh my goodness. I'm subtracting, but this isn't a logarithm. I can only combine things as a single logarithm with subtracting if this was log 2 of 6 minus, and we'll finish this up quickly. This would also have to be log 2 of something. What can I replace 3 with? What has to go in here? What number? An 8. And then this becomes You don't have to reduce your fraction if you don't want to. You can circle questions 5, 8, 11, and 13. No, 18. Look at this. Oh, yeah. Good recovery.